All right, good afternoon, ladies and gentlemen. Our objective for today is that students will be able to determine the growth factor and initial value of an exponential growth relationship by analyzing the equation. So we talked about growth factor. We're going to today talk about something else called an initial value and talk about in general what these equations actually look like, right? Before we get to that though, we're going to talk about one more real kind of life example. You're going to practice with that a bit, and then I'm going to talk to you about what these equations look like in general, okay? So scenario for today, it says mold can spread rapidly. For example, the area covered by mold on a loaf of bread that is left out in warm weather grows exponentially, right? So this is something that every year I tell myself I'm going to do. I'm going to bring in a piece of moldy bread, show it to you guys. But I got some bread from Fine Fare. There's so many preservatives in it that it's been sitting in a bag with some moisture in it for like 2 weeks, still has not molded, right? So what I'm going to do is I'm going to show you actually a video that's a time-lapse video of, I believe it's a tomato that has some mold growing on it, just to see how fast it grows and how crazy it looks, okay? So you're going to see that video right now. It's, I think, about a minute long or so, right? Then when you come back, we're going to talk about the scenario for today. So now that you saw that really cool looking tomato, I bet you're really hungry, right? So mold is something that grows exponentially. That means that it starts off growing slow and then it starts getting very fast, right? So what we're saying is that students at a middle school are conducting an experiment. They put a mixture of chicken bouillon, gelatin, and water in a shallow pan. They left it out to mold. Each day, the students recorded the area of the mold in square millimeters. So like, let's say this here was the Petri dish. It's growing every day. They're kind of measuring what's the area of it. So how much of the space is being covered by the mold. It says that the students came up with this equation here, y equals 50 multiplied by 3 to the x, to model the growth of the mold. In the equation, y is the area of the mold, and x is the number of days that have passed. So what I want you to try to figure out on your own first is, looking at this equation here, what do you think is the area of the mold at the start of the experiment? Because we're starting off with some mold. And then what do you think the growth factor is? So what are you going to be multiplying by? Now there's only two numbers in the equation, so you've got a 50-50 chance. So just try taking a guess before I give you the answer. So looking at this equation here, I'm just going to think back to the equation that we saw yesterday. So the equation yesterday was y equals 1,000 times 2 to the power of x. And remember, the 1,000 was how much of that plant started off on the lake, and the plant was doubling every month. So we've got a similar relationship here. In this case here, the starting area of mold is going to come from here. So 50 square millimeters is the starting area. So I'm going to label that here. And we also know that based on the equation from yesterday, it was doubling, so we had a 2 to the power of x. This one we have a 3 to the power of x, so this growth factor is actually going to be 3. It's going to end up tripling as we go. And that's our growth factor. So what we're going to do now is we're going to use this information. It's starting off with an area of 50 square millimeters, and it's tripling every day. So when you turn to the next page, the first thing that you're going to do is you're going to use that information to fill out this table here. So I'll help start you off. When we're talking about exponential growth and we talk about how much you start with, that always happens at time 0, right? Not time 1. So at time 0, when things started off, remember it said that we had 50 square millimeters of mold. Now, after 1 day, that equation told us that it tripled. So I need to multiply this by 3. So 50 times 3 gets you to 150. And then to go on to the next day, same thing. You multiply this by 3, same thing for the next day. Multiply by 3. So we're going to keep on multiplying by 3, and that is going to tell us how much mold we have each day. While I'm there, mold is your Zoom password for the day, all lowercase. Mold is your Zoom password. Okay, so after you're done filling out your table here, the next thing that you can do is you're going to try to answer the questions over here. So the first part, number 2, I'm going to do this with you. It says use the equation to try and verify the area of the mold after 5 days. So you should have this in your table already, right? The way that I verify that is I say, okay, 5 days means that this x is basically a 5. So I'm substituting x with 5. I'm going to say y equals 50 times 3 to the power of 5. You put that into a calculator, and that is going to give you the answer that should match whatever you have here for question number 5. Again, all I'm doing is I'm changing the x to a 5. So you're going to use that same approach to answer question 3 for 8 days, question 4 for 12 days, question 5 for 3 weeks. Now, number 6, a little bit different. It's saying, on which day is the amount of mold going to pass 1 million square millimeters? So you're looking for which day ends up getting you to a number that's over 1 million, right? I'm going to let you work that out. There's different approaches. If you're not sure, feel free to come to the Zoom session. I'll try to help give you some guidance, okay? Now that you're done with this part, we're going to look at the next page, which is talking about something called the standard form of an exponential equation. Okay, we've saw a couple of equations so far, and if you haven't understood them, that's fine, because right now I'm going to give you the tools that you need to make your own exponential equations, right? So every exponential equation that we're going to see, or most of them, are going to look like this for the rest of the unit. Y equals a times b to the power of x, all right? This is referred to as the standard form of an exponential equation, right? Kind of like when we talked about linear equations look like this. Y equals mx plus b. Exponential equations look like this. Y equals a times b to the power of x. So you have different types of equations. Now, when we have this equation here, we say that a is the initial value, and we say that b is the growth factor. So kind of like, remember when we talked about this here, we said that m was the slope, and we said that b was the y-intercept. So we have a similar relationship here, except instead of talking about slope and y-intercept, now we're talking about an initial value and a growth factor. So easy way to figure it out. What your growth factor is, your b, you're looking for the base of your exponential term. So the exponent is here. The number being raised to that is my growth factor. So when I looked at that mold equation, I know that b was my growth factor. So in this case, 3, because I had the exponent here. I know similarly that this here would end up being my a, which is my initial value. All right, again, when we talk about initial value, we're talking about time equals 0. So before anything happened, we started with 50, and the growth factor tells me that we're tripling. Okay, so I want you to try to practice with this. The goal for the remainder of the class period is for you to look at these equations here and try to identify the initial value and the growth factor. I'll do the first one with you. So let's look over here, right? I think the easiest thing to figure out first is your growth factor. So just like we did over here, we found the exponent here, growth factor 3. So I'm going to look at this equation here. I see my exponent here, if x is here. So the base of the exponent 2 is going to end up being my growth factor. Likewise, my initial value is really just the other number. So it's the number that I'm multiplying up front. It's the coefficient is the technical term. So 540. That's simple, right? You're going to do the same thing for the rest of these here. They're going to start to get a little trickier as you go down the list, right? But try your best, and then we're going to talk about these later during the Zoom session, okay? If you have any other questions, just make sure you come to the Zoom session. Once you finish with this, the back page, the push yourself for today, kind of like an extension, is just some state test questions that are related to exponential scenarios, right? Scientific notation, some stuff that we're going to see more later on this unit, okay? So good luck with the task. Again, please stop by the Zoom session if you have any questions.